AC machines to single phase induction motor. So on completion of this topic, you would able to know about shaded pole motor, components, working, torque, speed characteristics, applications. Here the shaded pole motor is given. So figure is showing this is the stator. This one is stator. Here this one is rotor. The stator is connected by the stator winding. This is the stator winding here. This is wounded to the stator, and here the stator will produces the flux, that is main flux, and here this is the stator flux, not main flux, and here the in rotor this is the cage rotor. Here the main flux and here the auxiliary flux. Here the place the copper shading rings. This is copper shading. Here north pole and south pole. This is shaded pole induction motor figure. Here the connection diagram of shaded pole induction motor is showing that here two pole shaded construction, two pole shaded pole construction. Here this is the pole is shading, this is the unshaded. Here shaded, this is the shaded pole, and this is unshaded pot. Shaded pot here, unshaded pot. This is also shaded pot, this is unshaded pot. Here this is the terminals for AC supply. Here see, this supply is in this way, the winding is connected in this way. This winding is called, it is connected to the stator, so that is called stator winding. Stator winding. Now here this is called shading pot portion is here the shading coil. This is called shading coil. This coil is called shading coil, and here also this is called shading coil. This one is rotor, that is squirrel cage rotor, that is squirrel cage rotor. Next, here the shaded pole motor, it consists of squirrel cage rotor. The stator consists of salient poles. The stator consists of salient poles. Here the poles are shaded. Each pole carries a short circuit copper coil called shading band or shading coil. Each pole carries a short circuited copper coil called shading band or shading coil. The portion of the pole which carries shading band is called shaded part of the pole. The portion of the pole which carries shading band is called shaded part of the pole. The remaining portion is called unshaded part of the pole. Once again I am repeating here. It consists of a squirrel cage rotor. Stator consists of salient poles. The poles are shaded. Each pole carries a short circuited copper coil that is called shading band or shading coil. Here the portion of the pole which carries shading band is called shaded part of the pole. The remaining portion is called unshaded part of the pole. Here, see here the shaded pole. Here the copper coil shading. So this is the portion is unshaded part of the pole, and this one is shaded part of the pole. This is the shaded part of the pole. So here this one is the copper shading coil. This is the copper shading coil. So this is the shaded pole, salient pole with shading coil. See this one. These are the shaded pole and shaded pole. Here this is the supply. Here this is the shading coil and this one also shading coil. This is unshaded portion. This is also unshaded portion. This is the stator winding supply coil. So this one is core. This one is core. Now see the shaded pole motor with shaded coil. How this will be here, how this will be connected. See, this is the here. See, observe this one shaded pole motor. See, can be single speed or tapped multi-speed as shown here. Electrically and mechanically simple. It is inexpensive but has poorest efficiency and starting torque. Best uses are usually household rather than industries. Here this one is if this is connected the high speed, this for this medium, this is for low. This is main winding shaded pole. This is the main winding and this is shaded pole coil and the rotor. See here, the graphics, see here, graphics shaded pole motor with flux distribution, how the flux will be distributed. How the flux is distributing. See, observe this one. Here they are showing 4-pole shaded pole construction. Here these are the shaded poles and this is the split. Here the copper wire 1 ton, copper wire 1 ton. Poles are north, south, north, south. The principle of operation of shaded pole motor. The principle of operation of shaded pole motor. The single phase supply is given to the stator winding. Due to the shading band on the poles, a rotating magnetic field is generated. Single phase supply is given to the stator winding. Due to the shading band on the poles, a rotating magnetic field is generated. A rotating magnetic field is generated. See here, the flux versus time. The waveform of stator flux here. The alternating flux here, it is in sinusoidal wave. So here T1, T2, T3, this is the alternating flux. This is the time and here this one is flux. Y-axis, along the y-axis is taken as the flux and along the x-axis is taken as the time. So now this is in sinusoidal waveform. This waveform is in sinusoidal waveform. Consider 3 instants T1, T2, T3 during positive half cycle of flux. See here, this is T1, T2, T3. These are the during positive half cycle. So here during the positive half cycle of flux at T is equal to T1, current through the stator coil and flux increases. Current through the stator coil and flux increases at T is equal to T1. Due to rate of change of flux, EMF is induced. Due to rate of change of flux, EMF is induced in the shading band by Faraday's first law. EMF is induced in the shading band, so Faraday's first law. This EMF causes current to flow in short-circuited shading band. So this EMF causes current to flow in the short-circuited shading band. So the direction of current gives by Lenz's law. So it causes increase of flux of stator field. Hence, there is a crowding of flux in the unshaded part. So, weakening of flux in the shaded part. The flux in the shaded part. So, crowding in the flux in the unshaded part. Since magnetic axis will be at the center of the unshaded pole. Hence, magnetic axis will be at the center of the unshaded pole. This is the magnetic axis. See here, this is unshaded pole, here the shading pole. This is the supply, the north pole is established. Pi m is the flux, maximum flux, main flux, and it is the bias. So, unshading ring flux. So, here this is the magnetic axis at t is equal to t1. At instant t is equal to t2, the stator current, hence flux, is maximum. The rate of change of flux is minimum, and the induced EMF is shading band is very small. The stator current, hence the flux, is maximum. The rate of change of flux is minimum. The rate of change of flux is minimum. The induced EMF in the shading band is very small. So, hence opposition to main flux is negligible. So, the main flux distribution is uniform. The main flux distribution is uniform. So, magnetic axis is the center of the pole. Magnetic axis is at the center of the pole. Now, here at t is equal, magnetic axis at t is equal to t2, that means the flux is maximum, the rate of change of flux is minimum, and here the magnetic axis is so center. Here this is the pi m. See here, hence opposition to main flux is negligible. So, why main flux is negligible? So, the induced EMF in the shading band is very small. See, this is the shaded band portion. So, here the magnetic, so rate of change of flux is minimum. So, EMF is induced is so almost nearly to 0. So, here hence opposition to main flux is negligible. The main flux distribution is uniform. The main flux distribution is uniform. Here working at t is equal to t3, the stator current and flux decreasing due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. So, now the EMF causes current to flow, the direction of which is given by Lenz's law. It opposes the cause of its production. It opposes the decreases of flux. So, the flux due to shading bands is in the same direction as the main flux. The flux due to shading band is in the same direction as the main flux. So, there is a crowding of flux in the shaded part compared to unshaded part. So, there is a crowding of flux in the shaded part compared to unshaded part. The magnetic axis is shifts to the center of the shaded pole. The magnetic axis shifts to the center of the shaded pole. So, here from this point to this point and this point to this point. The magnetic axis is, so here the magnetic axis is shifts to the center of the, so this is shading, so coil. So this is the magnetic axis. Here the flux is crowded here. So here there is a crowding of flux in the shaded part. This is the shaded part. The flux is crowded at t equal to T3. Here the main flux here in this way, and the S by S is shaded flux is in this way. So these flux are, so here these two fluxes are same direction at t equal to 3. T is equal to T3. So see here in before cases, in this case at t is equal to T2, at t equal to T2, here the stator current, hence flux is maximum, the change of flux is minimum, hence EMF shading is very small, so the opposition to main flux is negligible. So here the flux is distribution in uniform. See here, this is the flux at so t equal to T3, in direction same, so both are in same direction. Here shaded pole index, here the torque speed characteristics of shaded pole induction motor. Here see here this one, the shaded pole induction motor 0 to 100%. Here in between the starting torque is in between 0 to 100%. If the speed increases, it goes on slowly, it goes on increasing up to so certain speed, that is 70 to 80% of the synchronous speed. After that it will be decreasing. After that it will be decreasing. This is the characteristics of torque speed characteristics. Now shaded pole motor, here the shaded pole motor advantages. So what are the advantages? So it is simple in construction and cheap, simple in construction and cheap, and extremely rugged, and so no centrifugal switch is required. No centrifugal switch is required. It is simple in construction, cheap, and extremely rugged, and no centrifugal switch is required. So this is the shaded pole motor. This is the shaded pole motor. See this one. Here this is the stator, and here this one is the rotor. This is the rotor. Is the coil input supply. So this is core. Disadvantages. Here starting torque is poor, efficiency is very low, and very limited overload capacity. Here the starting torque is poor, efficiency is very low, very limited overload capacity. Then summary, in shaded pole motor, the necessary phases split is obtained by using a shading coil on one side of the stator pole. In shaded pole motor, the necessary phase split is obtained by using a shading coil on one side of the stator pole. So no centrifugal switch is required. So the starting torque is less. No centrifugal switch is required, and the starting torque is less. So this is about the shaded pole motor. Thank you.